Okay, let us discuss the following problem. So in this case you have to write down the product. So from alkene, so this is from alkene, so let us write easy problem this time you have. So you have to write down the major product of the following reaction. You have to also indicate the stereochemistry in the following cases. If necessary, then only. If there is no stereochemistry important, then you don't have to write the stereochemistry. You have to write major product. So let us say this molecule I have, and if this reacts with HCl, you have to write on the product. So there is a hydrogen and there is a Me group, there is a Me group, there is a Me group. Okay, so done. You have to use the Markovnikov rule. The hydrogen will go to the place where we already have more hydrogen. So the hydrogen will go at this point and chlorine will go at this point. So we will have something like this. So okay, so I have to make it single bond. So let us say, and I will have methyl group here, and here I will have another methyl group. Here hydrogen, here methyl group I have, and now I have to add hydrogen at this place, and chlorine is this place. Are you getting? Let us discuss the next one. So next problem you have. So this asks, please keep copying, these problems are easy one. So next is, we have this molecule. It's a 5-membered ring, and there is a double bond. This side we have CH3, and if I treat this compound with bromine CCl4, you have to write down the product. You have to also show the stereochemistry. Stereochemistry is important in this case. So done. Okay, so you see in this case, now bromine will basically add to NT. So you have CH3 this side and another bromine that is downside, but on this carbon bromine should have upside. Now this hydrogen should be downside because bromine anti. Are you getting or not? You will get one product this. Now this compound is basically chiral, so this carbon is chiral. You see, this carbon is chiral, even this carbon is also chiral. So you see this hydrogen Br, this are different group, this are, so you have this carbon as well as this carbon, both chiral. Now you can add bromine from the bottom, you can also add bromine from top, so you can get another isomer of the same compound. You will have this, and here you can have a bromine on the top. So something like this, bromine is here and CH3 is the bottom, that should go down. Now here you will have bromine on the bottom and hydrogen should go on top. So you will get both isomer. Are you getting or not? So this bromine and this bromine are anti. Here also bromine and bromine are anti. Only thing is, in this case the bromine is in this case bromine is up. So basically these two are. Now this compound will be racemic mixture because initially solution is optically inactive, and if the initially inactive solution I have, finally also mixture has to be have optically inactive. Are you getting or not? So this means I will get a racemic mixture. So these are two enantiomers. So I will get enantiomeric mixture. Enantiomeric mixture. Are you getting? So we'll get an enantiomeric mixture. So please keep copying. And let us say the problem third. So what this says, we have this compound 5-membered ring, and then I have here CH3 attached, and if I react with fast H2O2 BH3 in THF, that is hydroboration, BH3 in THF, solvent is THF, and the second is H2O2H minus. What will be the product in this case? So this is a hydroboration oxidation method, and this is a, if you remember this reaction, this is a syn addition. This is the one thing for this is, and another thing is this is anti-Markovnikov. So now you know the product, anti-Markovnikov. Are you getting? So this is anti-Markovnikov. So if this is something like this, so what will be the product? I will have a hydrogen I should attach at hydrogen should go at place where I already have less hydrogens. This hydrogen should go here and OH should go here, and both should be same side. So let us say, make me the product So if CH3 is up, hydrogen will go, and it should go down, and OH also should go down because both are syn addition. And now here I will have one hydrogen also, so this is one product. If OH, HOH both are adding from the bottom side, I will get another product if HOH both are on the top side. So we will have another product, this. So let us put hydrogen here on the top, getting, and CH3 on the bottom, and here you will have, just change OH on the bottom, top, and hydrogen on the bottom. So this is a syn addition. You see hydrogen and OH both on the back side of the plane. Here also hydrogen and OH both upside of the plane. So this is basically a syn addition, and again you will get a racemic mixture because initially the solution was optically inactive. So you will have a racemic mixture. Are you getting? So you will get a racemic mixture in this case also. So please keep copying, and then we will discuss the next problem. Okay, so let us see the D one is a easy one. So let me go to the next page. I think you have written. So I can use the next page, I think. So you have written this one. So the D says, D part of the question. This is the ozonolysis, reductive ozonolysis, easy one. Everybody knows this one. So I have CH3 here. And if I do reductive ozonolysis, what is the reagent for reductive ozonolysis? Did you remember? O3 is for ozonolysis. And if I want to do reductive ozonolysis, I have to take zinc or I have to take dimethyl sulfide. So CH3 whole twice S in H2O. So this is dimethyl sulfide. So basically now this is a reductive ozonolysis. What will the product? Have you written the product? Not it, just write. Okay, so what we have to do is we have to break this bond, and then product will be aldehyde or ketone. So here I will have aldehyde because I have a hydrogen here. So I will have this side O hydrogen. So this is one aldehyde, and this side I will have a ketone. Are you getting? So this side I will have a ketone. So simple. So you have to simply break the bond. So this side will have a ketone, and this side will have a aldehyde. So this is aldehyde, and this is ketone. Because we are doing the reductive ozonolysis, we cannot do more ozonolysis. We cannot do go up to the acid part. We have to stop the product either in ketone or aldehyde, because in reductive ozonolysis aldehyde further does not get oxidized. But if we have oxidative ozonolysis, aldehyde gets oxidized to acid. Are you getting? Let us discuss next one, E. I think you have written. If you have written this one, let us do this problem. Basically these are easy problems. We have this. Now there is a double bond, and if I treat with HBr in peroxide, HBr peroxide, let us say ROOR. Peroxide, this is H2O2, something like hydrogen, or you can have acetic peracid or any peroxide. So ROOR is denoting peroxide. So in the presence of peroxide, HBr addition is what? Did you remember? This is the anti-Markovnikov addition. So hydrogen will go to the place where I have less hydrogen. Are you getting or not? So hydrogen should go here and bromine should go here. So let us write down the product. So hydrogen I should add here, and bromine I should add here. So let me write bromine here. So this is the product. Are you getting? So this is the product of this reaction. Okay, let us keep copying, and we will discuss the next problem in the next slide. I think you have copied this one. So let us go for the next slide.